Hello my dear students, I hope you're all doing well. My name is Benatang Paton and I welcome you all to the channel Classroom where we learn together. So we will be continuing with where we stopped in the previous video. So in the previous video we were discussing about chemical equations and we will be continuing with chemical equations even in this video. So in the last class, in the previous video, we have learned about the three ways to represent a chemical equation. The first one was called the word equation. The second one was the skeletal equation, and the third one was the balanced chemical equation. We will be focusing on the balanced chemical equation because this is what is important. Okay, in class 10, if there is any question which is asked, is balanced chemical equation only. So you have to learn how to balance chemical equation. Okay, sometimes in the exam you are given word equations and you have to translate the word equation into skeletal equation. After translating to skeletal equation, you have to balance it. So it's a two-way process, so you have to learn both the method, how to translate word equations into skeletal equation. That is the first challenge. And after that, you have to learn how to balance the skeletal equation which we have just formed. So it's easy. Okay, believe me, it's easy, my dear students. It is easy. It is very, very easy. Okay, it is not at all hard. I am telling you. So I assure you that if you watch this video, you will understand. Okay, and some of you might have already understood from the previous video itself, though there we only did two examples like that, but you have already understood it. Now, to those who did not understand from the previous video, don't worry. In today's video, we will be discussing 4 questions and we will be discussing from your textbook. So I have your textbook here with me, the class 10 textbook. So this is the textbook class 10, okay, the front page cover, Nagaland edition. So if you have the textbook with you, please grab the textbook and go to page 15. We will be discussing from this exercise question. Okay, so which question are we going to discuss? We are going to discuss question number 5. So question number 5, which reads, translate the following statements into chemical equations and then balance them. So first of all, we have to translate all of these statements. These are called chemical reaction statements only. We have to translate them into chemical equations. Okay, and then after translating them into chemical equation, we have to balance them. So it's going to be very, very interesting. So without further ado, without wasting time, let's jump to a lesson and let's learn. But wait, before, let me grab my marker. Now I have to use this marker. This marker is my tool. Okay, it's my weapon to teach you. Okay, plus this whiteboard. So what are my tools? To stand here and then to be teaching you, I need 2 tools. One is this and the other is this whiteboard. Without these two, I cannot teach. All right, I cannot teach. Believe me, I cannot teach without these two. Okay, so to make it effective, I need this whiteboard and I need this marker. And what do I do with this? I utilize this. In the same way, from your end, you are watching this video, but then you are watching this video because you want to learn. Now let me tell you the truth about learning. The truth about learning is participation. Believe me, it's participation. If you participate, you learn. If you don't participate, you become a spectator. So you don't learn much. Okay, you don't learn much. So here we are talking about the amount, the degree. So how much do you want to learn? If you want to learn more, participate. Okay, so to participate, it's very simple. You grab a pen or a pencil and grab a notebook. Okay, open your textbook and let's do together. Okay, let's do together so that you learn. Okay, let's learn together. Okay, you should not learn alone. We should all learn together. So I'm here to teach you. So let's learn together. Okay, so with this positive note, let's go to our lesson. So let me copy down the question first. 5A. So question number 5A. Let me first write down the question A. So the statement reads, hydrogen gas combines with nitrogen, to form ammonia. So this is the statement. This is the statement of the chemical reaction. So now what we have to do is we have to convert this into skeletal equation. So let's do that. So how do we do that? Okay, how do we do that? In the previous video, I have told you that to convert any chemical statement into skeletal equation, you have to identify the elements and the compounds. Keep an eye, okay, keep an eye, observe, okay, observe, be observant here. Keep an eye for the elements or the compound. So if we read this statement, hydrogen gas, that means hydrogen is the element. So write down now hydrogen is an element, so for elements you have to write the chemical symbol. I repeat, for elements you will write the chemical symbol. So elements, if it is an element, then you write the symbol. So you write the symbol. I hope it's visible. Okay. Then for compound you write the formula. So please remember this, okay? That for compound you will write the formula. For element you will write the symbol. Hydrogen is a compound or an element? Yes. Anyone? Raise your hand. Yes, tell me, is hydrogen an element or a compound? Of course, hydrogen is an element. Okay, so we will write the symbol or the symbol or formula. Yes, it's the symbol. So H. Now, hydrogen is a diatomic. So let me give you some very common diatomics which you will need in this chapter. So diatomics. So from atomic number 1 till 20, there are 4 diatomics which are very, very common. We have hydrogen, we have oxygen, we have nitrogen, and we have chlorine. These 4, my dear students, remember them. Okay, very, very, very important. Remember them. These are diatomics. Now, why am I emphasizing on diatomic? It is because whenever you are to write any of these elements, I am telling you element, okay, not in their compound form, but in their elemental form, which is like this. Here, this is hydrogen. Hydrogen is an element. That means I have to write the elemental form of hydrogen. Whenever I am to write any of these elements, I have to remember to put 2. Why? Because it is wrong to write. Sorry, why am I striking it off? Wait, why am I striking it off? Which is wrong to write? It is wrong to write like this and proceed. It is wrong to write like this. Okay, it is wrong to write like this. This is wrong. This is not hydrogen. Hydrogen cannot stay like that. Hydrogen can only stay like this. Hydrogen is a diatomic. Di means 2. Remember, di means 2. Di means 2. Okay, so hydrogen is a diatomic molecule. Okay, diatomic atom. You can say diatomic atom. Okay, hydrogen is a diatomic atom. So diatomic, hydrogen gas, these are not relevant. Combines means plus. Okay, with not relevant. Then nitrogen, to form, that means chemical reaction will take place. So now my eye goes here. So nitrogen catches my attention. Okay, so nitrogen has caught my attention. So now I want to know whether nitrogen is an element or a compound. Tell me, students, is nitrogen an element or a compound? Yes, nitrogen is an element. Now, is nitrogen diatomic? Yes, nitrogen is diatomic. So that means we have to writing this will be wrong. For nitrogen, you have to put 2 here because nitrogen is also diatomic. To form means chemical reaction is going on. To form ammonia. So ammonia formula, you have to know the formula of ammonia. Now, ammonia is a compound, okay, my dear students. Ammonia is a compound. So the formula of ammonia is NH3. So please remember the formula of ammonia. See, there are some formulas which you have to know. Some common names of compounds like ammonia, water, which is H2O, carbon dioxide, which is CO2, okay, sulfur dioxide, SO2, like that. These some few very commonly occurring compounds you have to know. Okay, water, for example, is one. Then carbon dioxide, okay, sulfur dioxide. This you have to know. Okay, so that much you have to know. So we are done, my dear students. We are done with the first step. We have just translated the chemical reaction. Okay, the statement of the chemical reaction into the skeletal equation. So are we done? Now, can we proceed to the next question? Question number B. Can we proceed to question number B? No, sir. No. Balancing we have not done, is it not? Without balancing, we cannot proceed. The question wants us to balance also. So let's do balancing together. So let's balance. So how we do? We draw a line here, and remember, we are only allowed to write numbers here. So make sure that you have a space to write numbers here. Nowhere else you cannot write. Okay, elements are here, so elements are single, so they are all by themselves. But here, this is a compound. So remember, you cannot write anything here. You cannot write anything here. You cannot write anything here. You cannot disturb the formula. You cannot disturb the formula. If at all you have to write, this is the space available for you. So this space is available for you. Utilize the space to balance the compound, okay, or the element. So now remember the steps. So let me give you the steps again. The steps to balance a chemical equation. So the first step, what is the first step which I gave in the previous video? If you have written it down or if you remember, tell me the first step. Who will tell me the first step? Yes, the first step is identifying the elements. So ID the elements, capital I, capital D, identify the elements. ID the elements. Okay, identify the elements. ID the elements. So we always start from the left side. So let's start from this side. So if we go from the left side, this is the element. Identify this element. What is the name of this element? Hydrogen. Then we go ahead. Don't write this plus and all that, okay? Then we go to this. Let's identify the element. What is the name of this element? Nitrogen. Very good. Now, do we have any more element left? Now, this is the reactant side, isn't it? These are the reactants. These are the reactants. Every chemical reaction has got reactants and product. Without the reactants, they cannot be correct. They cannot be products. Okay. So these are the products. It's only one product, so let's write product. If I ask you what type of reaction is this, then what is the answer? Who can tell me? Though we have not discussed that topic now, there are 4 types of chemical reaction: combination, displacement, then double displacement, decomposition. Which one is that? Okay, you kindly let me know in the comment box. Okay, which reaction is this? Is it a combination reaction? Is it a decomposition reaction? Is it a displacement or a simple displacement? Do let me know in the comment box, and then I will check your comment. Okay, I'll give a like to it. I'll give a beautiful comment to it. Okay, and that's how you support me. Okay, so a small contribution from your side. All right, send your big love. Okay, we have to love each other. Okay, love so big that you can give to everybody. All right, so have a big heart and give love to everybody. All right, so let's give love. Okay, give me love also. Okay, I'll give my love to you, so you give me love also. Okay, so HN, then NH3. So the same elements will be found here. So let's copy paste. First step, okay, for the first step, which is identifying the elements, just copy paste the names of the elements which you have found, because they will be present here only. So HN, so H, then N. Check whether is it correct or wrong. You will see hydrogen here. Yes, you will see nitrogen here. So it is always correct. Okay, you can just copy paste. Don't waste your time. Now we go to the second step. Second step, what is the second step? Count the number of atoms. So this is the second step. Now we will be giving importance to these numbers. Do you see these numbers? Yes. Now these numbers will get importance. So count the number of atoms. How many hydrogen atoms here? 2. Right here, 2. How many nitrogen? 2. Right here, 2. How many hydrogen? 3, isn't it? This 3 belongs to hydrogen only. So 3. How many nitrogen? You don't see any number here. Okay. Here, you don't see any number here. So now this 3 belongs to hydrogen only. This, you don't see any number here. That means nitrogen is 1. We are done with the second step. I hope you are following. Easy, na? Okay. The third step, pause and balance. Now we are coming to the most important part, which is balancing. But before you balance, I have written pause. Why do I tell you to pause? I am telling you to pause so that you don't make mistake. See, okay, who needs balancing and who doesn't need balancing. Sometimes, okay, sometimes some already balance. Let's check. So does hydrogen need balancing? So what are we checking? We have 2 atoms of hydrogen here, we have 3 atoms of hydrogen. Are they balanced? No. Okay, they are not balanced. 3 and 2, they are not same, isn't it? These numbers have to be same. Okay, the numbers have to be same. So we have 2 atoms, we have 3 atoms, so they are not balanced. Okay, that means their scale will be somewhat like this. So in order to be balanced, they have to be at equal level. So this is not balanced because we have 2 atoms of hydrogen here and we have 3 atoms of hydrogen here. The numbers are unequal. That means imbalance. 2 nitrogen here, 1 nitrogen here. So even nitrogen is not balanced. So both of them are not balanced. So we have to, we have to balance it. So we'll be putting number, okay, on the mostly on the we put on the side which is less. So we should be putting here, not balanced, will be marked. We should be putting here, okay. We usually don't put on the side which has more. We only put on the side which has less. So basically by default we should be putting, okay, we should be adding numbers here and here also. But let's check. Only after checking we'll know. So now both needs balancing. So let's balance. Now balancing, there's a technique to balance, okay. Everything has got a technique. So I'll teach you all the technique. So if you ask me, then I'll give you 2 ways, okay. I do my balancing through 2 techniques. One is called the oxygen and hydrogen first. So I always follow the rule 1. So rule 1, so let me write here. Rule number 1 is oxygen and hydrogen first. Oxygen and hydrogen first. And rule number 2 is make it even. Make it even. So always start balancing with oxygen and hydrogen, provided they are there and provided they are not balanced. All right. So what is this oxygen and hydrogen first? By oxygen and hydrogen first, I mean that you have to start balancing with hydrogen if it is present there or oxygen if it is present there. Okay. So in every balancing, definitely there will be either hydrogen or oxygen. So if you see any one of them, provided they are not balanced, then we will start with oxygen and hydrogen first. Now let's have a look at our chemical reaction. Now have a look. Do we have oxygen? No. So oxygen is not there. Then do we have hydrogen? Yes, we have hydrogen. So we will start balancing with hydrogen first. This is called oxygen and hydrogen first. Always start first with oxygen and hydrogen. All right. So we'll balance hydrogen first. So here we have 3 hydrogen, okay, and then here we have 2. Now, how do we? I told you earlier that if at all we have to put, it should be here on the lesser side. This side is already more, isn't it? This side is already more, so we don't, okay. If we put here more again, it will become more imbalance. So this side is less, so we should be adding extras here. So we should bring the balance from this side, the one which is less, okay. So let's try. Now here we have 3, here we have 2. So what we have to do is we have to make this side also 3. We have to make this side also 3 because that side is 3, isn't it? So we have to make this side also 3. But now you tell me. Now see, the relationship is multiplication. So here multiplication will take place, and then you can write a number, or you are to write a number, okay, which will multiply with 2 and it should give you 3. So do we have a number? Do we have a number which we can write here, which on multiplying with 2, remember my dear student, the relationship is always multiplication, okay. It is always multiplication. So here also it will be multiplication only later on, okay. We will be multiplying something. So what number do you write here which on multiplying with 2 will give you 3? Do we have such a number? Is it 1? If you write here 1, it's 2 into 1, which is 2. That's not giving you 3. Is it 2? If you put here 2, then it goes to 4. Then we have exceeded the number. We are supposed to get 3, but we got 4. So what number do you write here? What number do we write here? No. Okay, we cannot write any number. There is no number which you can put here, which on multiplying with 2 will give you 3. Understood? So sometimes such a scenario takes place. You know why this scenario is taking place? This scenario is taking place because 2 is already here. Okay, 2 is already here. And then now we have to refer to the timetable of 2 for balancing. So because 2 is already here, now it is difficult to get 3. Had it been 1 here, it will be very easy, isn't it? Had it been 1 here, it will be 1 into 3. So what do you put here? 3. This 3 you will go and put it here. But it is not 1, it is 2. So that means we cannot ignore this 2. This 2 is there to stay. This 2 is here, so it will always stay. So we have to address this 2. We have to consider this 2. Okay, so with 2 here, we are not able to find a number here which will multiply with 2 and give you 3. So what do we do now? That means like we will say that this chemical equation cannot be balanced. Is it? Is it an unbalanceable chemical equation? No, there is no chemical equation which cannot be balanced. Okay, every chemical equation can be balanced. Then what do we do here in such a situation? No need to worry. So whenever we come across such a situation, then we have a way out, which is now in such a situation what we have to do is we have to select a common number, okay, which is found in both the timetable of 2 and the timetable of 3. I repeat, we have to search for a common number which is found, or we have to search for a factor which is found in both the timetable of 2 and the timetable of 3. So let's have a look at the timetable of 2 and 3. So if I write the timetable of 2, is 2 1s are 2, then 2 2s are 4, then 2 3s are 6. Then side by side, if I write the timetable of 3, it's 3 1s are 3, 3 2s are 6, and 3 3s are 9. Have a close look at the factors here, at the numbers here, and tell me, do you see any common number? Do you see any common number? Is it 4? Is it 3? Is it 9? No, it is 6, isn't it? It is 6. 6 is common to both 2 and 3. So that means we should be aiming for 6 here and not 3. So we should aim for 6 here. Similarly, even this also, okay, he will aim for now 6. Understood? This is how we bring about balancing. Okay, whenever this situation comes up. What situation? The situation where 2 is here and then we are supposed to get 3. This is an impossible scenario. So in such a scenario, you refer to the timetable and select a number which is common to both the numbers. Which numbers? We are referring to these 2 and these 3. Okay, and then select the common number and run for that number. So 6 can be found in the timetable of 2, 6 can be found in the timetable of 3. So now we can balance it. So now you tell me, 2 into what number gives you 6? Very easy, 2 times 3. So this 3 you will write here. Understood? So the number of hydrogen is become 3 2s are 6. Then likewise, okay, without delay, go here and correct this first. So 3 is already here. 3 into what number will give you 6? 3 into 2. So this 2, where will you write? This 2 you will write here. You write here 2. So 2 3s are 6. So 2 3s are 6. But wait, these 2, okay, these 2, now this is a compound. So this is a compound. So now this 2 belongs to nitrogen also. Okay, so these 2 belongs to both nitrogen and hydrogen. Hydrogen will utilize it and say that my number is 6. Okay, very well. Then nitrogen will do the same thing. Then these 2 belongs to me. So nitrogen will also say that means so my number also shoots up to 2. So now the number of atoms for nitrogen will change. It will be now 2. So no more 1 here. Okay, no more 1 here. Now it will be 2. Understood? It will be 2. Now you see. Now you see. So by putting these 2, okay, which came because we had to balance hydrogen. There was 3 here. So by putting here 2, we got 6. So this number, this 2 came from here. Okay, this 2 is this number. So which has helped hydrogen become stable. But these 2 also belongs to nitrogen. So automatically the number of nitrogen changes to 2. Understood? Now you see. Now you check. The number of nitrogen atom here is 2. The number of nitrogen atom here is 2. Balance or imbalance? It's balance. So automatically, okay, automatically nitrogen has balanced itself. I hope that's clear. All right. So this was question number A. We still have 3 more questions. So I will be erasing it. I hope that you have copied it down. If not, you kindly copy it, pause the video and copy it. Okay. All right. Assuming that you have done it, you have copied it. Now we'll go to the next question. So you tell me, is it difficult or easy? Yes, it's easy, isn't it? It's not difficult. So it's easy. Like I said, it is very, very easy. Now let's have a look at the second question, question number B. Let me write down the statement here. Hydrogen sulfide gas burns in air to give water and sulfur dioxide. So this is the second question which we will try together. Now, first thing, let's read the statement. Hydrogen sulfide gas burns in air to give water and sulfur dioxide. All right, we have read the statement. So what do we do now? After reading the statement, we are looking for elements and compounds. All right. So on reading the statement, this catches my attention. Hydrogen sulfide. All right. So is hydrogen sulfide an element or a compound? Yes. Who can tell me? Who can tell me that hydrogen sulfide is an element or compound? Very good. Yes. Hydrogen sulfide is not an element, but rather it is a compound. So hydrogen sulfide is a compound. Okay. Then these things are, we are not going to use it. Burns in air. This is important. Remember class, air means oxygen. In chemistry, air means oxygen. Okay. To give means the arrow will come. Water and sulfur dioxide. Water, element or compound? Element or compound? Compound, isn't it? Sulfur dioxide, element or compound? Again, compound. Okay. So now, but then there is a problem. Sir, there's a big problem. There's a big problem. Hydrogen sulfide. How do we write hydrogen sulfide? How do we write hydrogen sulfide? So what is the correct formula of hydrogen sulfide? Anyone? Does anyone know the correct formula of hydrogen sulfide? All right. Some of you already know. Good, good, correct. So the formula of hydrogen sulfide is H2S. But then, what about those who don't know? What about those who don't know? So how do we know? Okay, and then should we memorize it? Should you memorize it? The one who got the correct answer, did you memorize it? If you have memorized it, then no, don't memorize it. Then if I ask you from where you learned, then where did you learn? Where did you learn the technique how to calculate or how to find out the formula of compounds like hydrogen sulfide, aluminum chloride, barium sulfate? From where did you learn? Yes, class 9, isn't it? In class 9, you have learned last year. Okay, so you did not pay attention. So you did not learn. So now you need to know. Okay, now you need to know. So don't worry. Let this be a revision also. So now let's learn how to find out the formula of compounds. Remember, we don't memorize. Let us learn. Okay, let us learn. Let us take our time and let us learn. Okay, because memorization, there are many things to memorize. Okay, so how much are we going to memorize? Better learn so that we don't have to worry. Okay, so that we don't forget at all. So let us learn how to find the formula of hydrogen sulfide. So let me just write here. Okay, so hydrogen sulfide, the first step, let me show you. So the steps to finding the formula of a compound. So the step 1 is, what do we do? You write the compound. Write the compound. What do you mean by write the compound? So write the compound here. Hydrogen sulfide, whichever compound formula you have to find out, write the name of the compound there. Step 2 is write the symbol. So write the symbol. So let's write the symbol of hydrogen, which is H. Okay, it's asking for the symbol. Okay, it's asking for a symbol. Don't write H2. Got it? It's asking for the symbol. So you have to know the symbol. The symbol of hydrogen is H. And sulfide. What do you think is sulfide? Is it sulfur? Is it sulfur whose atomic number is 16? Yes, it's sulfur. So sulfide means sulfur. All right. So this was the symbol. We have just written the symbol. Then third step, number 3 is write the valencies. Write the valency. Whose valency? Kiska valency. We have to write the valency of hydrogen and we have to write the valency of sulfide or sulfur. Now the question is, but sir, I don't know what is valency. So what is this valency? All right. So what is this valency? See, my dear students, valency is the number of atom. Okay, the valency is a number of atom. Valency is a number of electron that an atom may lose or gain to become stable. I repeat, valency is the number of electron that an atom may lose, means donating, or receive, means accepting, to become what? To become stable. You know that atoms like to be stable, but naturally there are only few elements which are very stable out of the 118 plus elements which we have discovered. There are only few which are naturally stable. Most of them are naturally unstable, so they want to be stable. And how do they achieve stability? By donating. Metals, they donate electron, they lose electron, and then non-metals, they receive electron, they gain electron. So by donation, by losing, by gaining, like that. Okay, so the number of electrons that an atom, that an element loses to become stable is called valency. So now we have to write the valency. So what is the valency of hydrogen? Hydrogen has one electron only. Okay, atomic number of hydrogen is 1. So hydrogen has only one electron. So is he stable? No, he is not stable. So he needs one more electron. So if he receives the one more electron, he becomes stable. So hydrogen will receive one electron to become stable. So this electron is the valency of hydrogen, so which is 1. Now let's find for sulfur. Sulfur ka atomic number is 16. Sulfur atomic number is 16. So sulfur is here. So there are 16 electrons. So 2 will go here in the first shell. So 16 minus 2, how much? 16 minus 2, how much you get? 14, nah? So there are still 14 electrons left. Then hydrogen, sulfur will take the second shell here. 8 electrons will go. 1, 2, 3, 4, 5, 6, 7, 8. So 14 minus 8, how much? How much is it? 8, 9, 10, 11, 12, 13, 14, 6. So you are left with 6. 6. So 6 more electrons are left. So 6 electrons are left here. So 6 will go here. Okay. The 6 electrons will occupy the third shell. But 6 is not a stable number. The stable numbers are 2, 8, 18, 32. These are the stable numbers. 6 is not a stable number. So that means sulfur is not stable. But sulfur will not accept that. Okay, sulfur will not accept that. He will say, okay, but I will not remain like this. Let me do something. What will he do? Now he will say, let me gain 2 electrons. Now can he gain 2 electrons? Yes, you can gain 2. Okay, you can gain 3 also. All right, so you can gain 2. Maximum you can gain is 3. Okay, so maximum you can gain is 3. Just keep it at 3. If it is 4, then it's mostly covalent. Okay, sharing. So let's keep it 3. So maximum you can gain is 3. So how much does sulfur need? 2. So he can easily gain 2. So sulfur will gain 2 and then he will become 8. So 8 electrons will be revolving in the third shell. 2, okay, his original electrons are 6 only, but he gained 2, is not, because 2 you can easily receive. 3 also you can easily receive. Okay, so 1, 2, 3 you can receive. So he receives 2. So with the help of these 2 electrons, he achieves this stable number, which is 8. So valency becomes 2, because by receiving 2 he becomes stable. So this is 2. All right, so now what we do, we go for cross multiplication. So you go for cross multiplication, and then you write the formula which is H into 2, H2, S into 1 is S1, but we don't write S1. It's understood that there is 1 there, so you just write H2S. So this is how you write the formula. Okay, this is the formula of hydrogen sulfide. So this is the step. Remember this, you will be needing this step, so kindly copy down. So now that we have the formula for hydrogen sulfide, let's write the statement. So hydrogen sulfide, how will I write? I'll write H2S. H2S. Gas burns, with these are not relevant, in air means oxygen, so O. Should I write O or O2? Look there, look there. Should I write O or O2? Yes, O2. Why? Because oxygen is diatomic, okay? To give what? To give water. Water, what is the formula of water? Very good, H2O plus sulfur dioxide. What is the formula of sulfur dioxide? SO2. SO2. Now, let's balance this one. I hope I have enough space. So, first step, identify the elements. ID the elements. So, let's identify the elements. So, we have hydrogen here. Let me write small. Then we have sulfur here. Then we have oxygen here. Okay. So, these elements will be found here. So, let's just write HSO. Okay, without wasting time. Then the second step is count the number of atoms. So let's count the number of atoms. How many hydrogen? 2. So write here 2. How many sulfur? 1. So we can write here 1. How many oxygen? 2. So we can write here 2. Then we go here. And then let's count. How many hydrogen? 2 here. So let's write here 2. How many sulfur? 1. You don't see any number here, which means 1. And how many oxygen? How many oxygen here? Yes, how many oxygen? Do you see 2 here? Yes, so 2 here. But then you have oxygen here also, isn't it? So both of these products, they have oxygen in them. So in total, how many oxygen are there? 2 here, 2 plus how many here? 1. 2 plus 1? 2 plus 1? Yes, 3. So 3 oxygen. I hope you all understood. Alright. So now let's check. We are done with point number 2. Let's go to point number 3, which is pause and balance. So take a momentary pause. As you pause, you observe who needs balancing. So hydrogen seems balanced, all right. So no need to disturb. Sulfur also seems balanced, so all right, good. So it's oxygen which needs balancing. So let's balance oxygen. All right, let's balance oxygen. So how do I start? Well, rule number 1, we always start with oxygen and hydrogen first. So hydrogen is there, but hydrogen is already balanced, so no need to disturb. So we start with oxygen. Now we'll balance oxygen. Now you see, there's a catch here. If at all, okay, if at all there, how do I put it? If at all there is any question in balancing which is difficult, then this should be the question. Okay, such type of question should be considered as difficult. So let's put this under star mark. Let's give 3 stars. Okay. So if at all, if there is any question, okay, regarding balance of chemical equation which is difficult, then I will put it under this category. This is a challenge for some students. Okay, but actually it's easy. I will teach you how easy it is. So I'll teach you, okay, how easy it is, and then after this, this will be very easy. Okay, you don't need to worry. Now let me tell you why I am putting this under the hard category. First and foremost, oxygen is imbalance. Oxygen is imbalance. Okay, this side 2, this side 3. Oxygen is imbalance, so we are going to balance oxygen. Okay, for which we will put numbers like that. But the catch here is that oxygen is found in both the products. Oxygen is found here also, oxygen is found here. Okay, so this causes a problem. This can stretch. Okay, this will make you erase, then again put, then erase, like that. Okay, this pull is there. Okay, this like this, what do I say, this pull is there. Okay, let's say pull. So it will stretch you, it will pull you. Okay, you will put one number, then again it will be mistake like that. It will pull you a lot. It will consume a lot of your time. So to save time, one method is there, which is called make it even. So we will apply the rule number 2, which is make it even. Whenever you come across such a situation, what is the situation? When the element that you have to balance is found in, okay, is found in 2 sides. Okay, sorry, is found in 2 of the react products, or it is found in 2 of the reactants. Sometimes it is found in the reactant side. Okay, sometimes in our case here, it is found in the product side. So here oxygen is found in both the products, so balancing this, okay, requires us to be very careful. So remember, we'll use the second rule, make it even. So now what is this make it even? See, the make it even rule is this. If I ask you what is the number of oxygen here, the answer is 2. Okay, and if I ask you what is the number of oxygen in this compound, it is only 1. So when I say make it even, that means we have to make this also 2. Okay, because here is only 2, isn't it? So let's make this also 2. So how do I make this 2? Remember, I told you that you cannot write anywhere. Okay, you cannot tamper with the formula. You cannot tamper the formula. Let the formula remain as it is. So where are you allowed to write? You are allowed to write here. You are allowed to write here. So we have to make this oxygen 2. Okay, we have to make this oxygen even. Okay, we have 2. 2 is an even number. So here, no number. So let's make it 2. Okay, let's make it even by writing here 2. So I've written here 2. Now this oxygen is also even. If I ask you how many oxygen, you will say 2. How many oxygen here? 2. Even, even. This is called make it even. This is the make it even technique. Okay. So now 2 oxygen here, 2 oxygen here. So the number of oxygen on the product side has changed. How many oxygen now? Yes, it's 4. So let's erase this one. So the number of oxygen has changed. It is now 4. All right. Now after that, just keep it like that. Okay, just keep it like that. Now bring the necessary changes which has been brought by these two. Remember, this is a compound. Okay, hydrogen and oxygen together, water, this is a compound. So these two which you wrote will also affect hydrogen. So by writing 2 here, you have helped oxygen become even, but these 2 will also belong to hydrogen. So 2 2s are 4. So the hydrogen number will change to now 4. All right. Now you see 2 hydrogen, 4 hydrogen. Hydrogen has become imbalanced. So now we will go to hydrogen because the rule is oxygen and hydrogen first. We have already touched oxygen, so keep it like that. Okay, now we will focus on hydrogen. So we'll go to hydrogen. Let's balance hydrogen. Here we have 4 hydrogen, here we have only 2. So what we do, we will put the number here. So remember, the relationship is multiplication. So our goal is to make it 4. So what number do you write here? Okay, so that on multiplying with 2 will give you 4. Very easy. You put here 2. So this 2 where you put here. So now you have just put 2 here, because of which the number of hydrogen has become 4. So 2 2s are 4. But this 2 also belongs to sulfur. So the sulfur number has shot up to 2. So now this becomes 2. Alright, this becomes 2. Okay, now done, correction also done. Okay, we have brought the necessary changes. Okay, don't be in a hurry. Right, don't be in a hurry. Take your time. Whenever you write any number before the compound, okay, make sure that you address the changes also. Many of you, what I see is that you will write here and then you will forget about sulfur and then you'll go ahead. Whereas these 2 affect sulfur, so don't forget to bring the changes. Do the correction. Okay, be very careful when you are dealing with compounds. Elements though, it's all right. Elements though, it belongs to them only. But compound though, you have to be extra vigilant. Okay, so these 2, so 2 sulfur, 2 sulfur. Now here only 1 sulfur. Okay, so now we will work on sulfur. So let's work on sulfur. So let's make this 2. So 1 is here, so we have to make it 2 here. So 1 into what number will give you 2? The answer is 2. So you will have to write a 2. 1 into 2 will give you 2. These 2, where do we write? These 2 you write here. Alright, so you write these 2 here. So you have written these 2 here, because of which the number of sulfur has become 2 sulfur. But these 2 will also affect oxygen, isn't it? So how many oxygen now? It will be 2 2s are. So 2 into 2, which is 4. So 2 2s are 4. 4 plus how many oxygen here? 2. So 4 plus 2 oxygen. 4 plus 2, how much? 6. So the oxygen number again has changed to 6. Alright, the oxygen number has again changed to 6. Now this side only 2 now. So let's change this one. So this is 2. Now oxygen is only found here. Oxygen is only found here. So 2 into what number will give you 6? Because the number is here 6, so I have to balance it till 6. So 2 into what number will give you 6 here? You write here 3. So 2 3s are 6. So this number, what you wrote here, should be written here. Alright, and this is how you balance. Now let's check. Okay, let's check whether is it really balanced or not. Let's check. How do we check? This is how you check. 2 2s are 4, so 4 hydrogen here on the reactant side. Okay, 4 hydrogen. On the product side, how many hydrogen? 2 2s are 4, so hydrogen is balanced. 2 sulfur on the reactant side, 2 sulfur on the reactant side, balance. 6 oxygen in the product or reactant side, sorry. 2 oxygen plus 4 oxygen, 4 plus 2 6, 6 oxygen in the product side, so balance. So all the elements are balanced, and this is how balancing of chemical equation is done. Is it difficult? No, it's not difficult. It's not. It is not difficult. Okay, it is very, very easy. All right, so we are done till B. Now let's continue. Let us do the other two also. So we'll write the next question, question number C. So I'm going to erase this. I hope you have copied it down. Now we will do the third question, question number C. I don't know, maybe this video will be a little lengthy, but I'm explaining to make sure that you understand. So even if it is lengthy also, if you're learning, then that's what matters, is not? So I'm happy if you're learning. If this video helps you, then I'm most happy. Now we will do the next one, question number C. So barium chloride reacts with aluminum sulfate, reacts with aluminium reacts with aluminium sulfate. Reacts with aluminium sulfate to give aluminum chloride, or is it aluminium? Aluminium, ALUMINIUM. I think it's aluminium chloride, and a precipitate of barium sulfate, and a precipitate, PRICIPITATE, precipitate of barium sulfate, BARIUM SULPHATE, barium sulfate. So this is the third question. Let's do the third question together. So the statement is given to us. The statement of the chemical reaction is given to us. First of all, let us read the statement. Barium sulfate, and as we read the statement, keep an eye for the names of the elements and the compound. So barium chloride, this catches my attention. Okay, reacts with aluminium sulfate, another one. Okay, then to give, that means chemical reaction will take place. For to give, we will write the arrow, and aluminium chloride, another compound, and a precipitate, this is not needed, of barium sulfate. All right, now this question is going to be interesting. Well, these are all compounds, and then the trouble with compounds is that we have to derive their formula. So let's learn. Okay, let's learn. This is what you have learned in class 9. So let's learn again. Now, oh yes, now to solve this question, you will need one more. Okay, we will need one more thing which we have learned in class 9. What could that be? Anyone? While finding the formula for these compounds, we will be needing help. Okay, now you have already been introduced to that in your previous year, in your previous class 9. What am I talking about? I'm talking about the polyatomic ions. So the polyatomic ions, we need the polyatomic ions. So let's bring the polyatomic ions. Do you remember the polyatomic ions? If not, then you have to study. Okay, so you need to study the polyatomic ions. All right, so let's write down the polyatomic ions here. So let me write down the polyatomic ions here. Polyatomic ions. The first one is ammonium. NH4. Then we have hydroxide, which is OH minus. Then we have nitrate, which is NO3 minus. Then we have hydrogen carbonate, these are together, HCO3 minus. Then we have carbonate, which is CO3 minus. Then we have sulfide and sulfate. Sulfate, the formula are SO3 minus, SO4 minus, and finally we have phosphate. The symbol is PO4 minus. Well, my dear students, you have so much to study. All right, you have so much to study. So this is another thing which you have to know. All right, so there's so much for you to study. Okay, so you have to know this. Without the knowledge of this, finding the formulas of compounds is going to be very, very challenging for you. So please, okay, please make sure that you remember this. All right, now assuming that you know this, okay, let's find the formulas or the formula of this compound one by one. So okay, we'll try to find here barium chloride. So we will find the formula of barium chloride. Barium chloride we will do together. Okay, so the first step is in the previous question I have written, which is we will be writing their symbol. So barium ka symbol is Ba. All right, write the symbol of barium. Chloride, okay, chloride is chlorine, so you'll have to write Cl because chlorine ka symbol is Cl. Okay, then what you have to do is, now after that you have to write the valency of barium. Now what is the valency of barium? I know the valency of barium, but then I will not write it. Let's find it out, the valency of barium. Now, do you know the atomic number of barium first? First of all, let me ask you, who knows the atomic number of barium? It is not found in the first 20 elements. Okay, it is beyond the first 20 elements. It is beyond the first 40 elements also. So barium atomic number is 56. If I'm not mistaken, it's 56. Yes. So barium atomic number is 56. Wow, so big. So 56 electrons. Barium carries 56 electrons. Now then, how will we find the valency? So let me teach you how to find the valency of big atoms. Okay, it's very simple. It's very simple. You will learn. I will do one and then you will learn. Okay, I assure you that you will learn. So let's learn how to find the valency of barium. Remember, the stable numbers are 2, 8, 18, 32. Okay, these are the stable numbers. 2 is for the first shell, for the second shell is 8, for the third shell is 18, for the fourth shell is 32. You already know, nah? So barium. So this is the let's say this is the first shell of barium. So 56 electrons are there. So in the first shell, which is the K shell, so this is our barium. The first shell, how many will go? 2 will go, nah? 2 electrons will go. So 2 electrons will go. Is it too small? Let me write a little bigger, nah? So this is our barium. In the first shell, 2 will go. Okay, so 2 have left. So 56 minus 2. 56 minus 2 will give you 54. So still 54 electrons are left. So they need to be filled into the orbitals, to the shells. Okay, so now we go to the second shell. In the second shell, how many electrons will go here? 8 electrons will go here. We have 54 electrons, so send 8 here. So 54 minus 8. So if we subtract 8 from 54, we get 46. So still 46 electrons are there. I hope you are following. Okay, from 56 there are 56 electrons, so we will send 2 to the first shell because maximum of electrons which can go to the first shell is 2. Then remaining is 54. From 54 we will send 8 because maximum number of electron which the second shell can hold is 8. Okay, then we still have 46 electrons. They need to be given shells. So we go to the third shell. Here the maximum number of electron is 18. Do we have 18? Of course, we have 46 electrons. So aram say 18 we can get. So 46 minus 18. So 46 minus 18, how much is left? How many electrons are left? 46 minus 18, 28. The answer is 28. So we still have 28 electrons. So now let's go to the next shell. So the next shell, as per the series, it should be 32. So this shell, okay, this shell will require 32 to be stable. This is the first, second, third, fourth. This is the fourth shell. This is the fourth shell. So the stable number for the fourth shell is 32, but our barium has only 28. Our barium has only 28. So what he will do, he will not run for 32. He will say that okay. So to be stable in this shell is 32. Then barium will say okay. Then what I will do, I will not run for 32. Let me not go for 32. Rather, what I will do, I'll settle for 18. Okay, because there are, see, I have 28 electrons with me. I have 28 electrons with me. To aim for 32, 28, okay, 28, 29, 30, 31, 32. 4 electrons. 4 electrons. Nobody will give you 4 electrons. Okay, nobody will give you 4 electrons. Maximum what you get, 3. Okay, so 28, 29, 30, 31, 32. Unfortunately, the number is 4. So barium knows that he will not receive 4. So what he will do is, he will not aim for 32. Rather, he will say, okay, since I'm not going to receive 4 electrons, what I will do is, I will settle for 18. Okay, 18 do I have? 18 do Aram say I have, is it not? After 18, there will be some remainder left. So he will go for 18. So he will say, okay, I'll settle for 18. So send 18 electrons here. So 18 electrons will be sent. 28 minus 18, what is the answer? 10. So still 10 electrons are left. Okay, then to accommodate the 10 electrons, he will go to the next shell. Alright, then the next shell, what he will do? Same thing, okay, what he did here. So the electrons which he will send here should be stable. So he will say, okay, I have 10 electrons. If I have 10 electrons, the nearest stable number is 8. Okay, just like when he had 28 electrons, the nearest stable number was 18. He went for 18, isn't it? So now he has only 10 electrons. So what he will do, he will observe the stable numbers and he will find that, oh, 8 is very near. I can go for 8. So out of 10, let me go for 8. So he will send 8 electrons here. Okay, so now 10 minus 8, what am I writing? 10 minus 8, what is the answer? 2. Now finally 2 electrons are left. So these 2 electrons, what he will do, he will bring it to the next shell and then he will keep it here. Okay, now these 2 electrons, okay, these 2 electrons, remember, these 2 electrons is unstable. Remember, in the remember an atom, okay, an atom can only have 2 in the innermost shell. Remember that. Okay, the number of electrons in the innermost shell is 2, but in the outermost shell he cannot have 2. So what he will do, he knows that, okay, this is unstable, but he doesn't mind. So he will say, okay, no need to worry, I'll donate these 2 electrons. Okay, so this becomes the valency of barium. So barium will let go of these 2. Okay, barium will let go of these 2. Okay, so this is how barium adjusts. So see how smart is barium? 28. This was the number of electrons that barium had, but knowing that, okay, but knowing that 28 is not stable, he runs for 18. Okay, then he is left with 10. Knowing that 10 is not stable again, he runs for 8. Okay, that way he has managed to retain most of his electrons, and finally he is left with 2. Now 2 in the outermost shell is unstable. Okay, 2 in the outermost shell is unstable, but barium doesn't mind, so he will say, it's okay. Okay, take it away from me. Okay, I'll donate this one. Okay, take it away. Whoever needs it, take it away from me. I'm most happy with this. Okay, so this will go away. And look at these numbers. They are all stable numbers only. 2 in the innermost shell is stable. 8, 18, 18, 8 stable numbers. Okay, and so the valency of barium is 2, because barium lets go of 2 electrons to achieve stable state. Understood? So barium valency is 2. Chlorine valency, then now you have to know the atomic number of chlorine. Chlorine is 17. So chlorine atomic number is 17. So if we adjust 17, how will it be? So chlorine is 17. So first shell 2, second shell 8, third shell how much? 7, isn't it? 2 plus 8, 10. 10 plus 7, 17. So here there are 7 electrons, very near to becoming 8 if he receives 1. So if he receives 1, he becomes 8. Can he receive 1? Yes. So this 1 becomes the valency of chlorine. Chlorine will receive 1. So valency of chlorine is 1. So the formula is cross multiplication. What you get? Ba into 1, which is Ba, and Cl2. So this is the formula of barium chloride. All right. So let's write it. Barium chloride. So BaCl2 reacts with, so plus, let's write the formula of aluminum sulfate now. So let's find the formula of aluminum sulfate. Let me erase this now. So let's find the formula of aluminum sulfate now. Aluminum sulfate. So the first step is write the symbol. Aluminum symbol is Al. Sulfate, well, sulfate is sulfur. Okay, so it's no, sulfate is not sulfur. Why do I say sulfate? Sulfate is not sulfur, sorry. Sulfate is a polyatomic ion. Sulfate is here, my dear students. Sulfate is here. So you will be writing SO4. Remember this one, the one at the top. Okay, the one at the top is valency. Okay, the one at the top is valency. How did I teach my students at school? Let me show you. So how I taught them like this. It's like this, isn't it? So I told them to draw a car. That's it. Okay, this is how I taught them. So the car body becomes a symbol. So sulfate, you will write SO4. Okay, and then this one becomes the valency. So the valency of sulfate is 2. Okay, don't write the minus. Now aluminum ka valency. So what is atomic number of aluminum? Atomic number of aluminum is sodium, magnesium, aluminum 13. So aluminum is 13. Aluminum is 13. Excuse me. Now so let's arrange. First shell 2, second shell 8, and third shell 3. So in the third shell there are 3 electrons. 3 is not stable. Okay, so what will aluminum do? Can he lose this 3 electron? Yes, you are allowed to lose 3 electrons. You can lose 1 electron, you can lose 2 electrons, you can lose 3 electrons. Maximum 3 electrons you can lose. Similarly, you can gain 1, you can gain 2, you can gain 3. So aluminum will lose 3 electrons. So this becomes the valency of aluminum, 3. So aluminum loses 3. All right. Now remember, this is a compound. Okay, this is a compound. So put a bracket here. This is an element, so no need to put bracket here. Element, no need to put bracket. This is a compound, it's not. We have sulfur and oxygen together. So sulfate, don't forget to put bracket. Okay, see, these are all polyatomic ions. Here, don't forget to put bracket. So put a bracket. So now what will happen? Cross multiplication will take place. We always start from the left. So the formula is Al into 2, so Al2. Okay, and then this one SO4, and then bracket, this 3 will be multiplied. You write it there here like this. So Al2 SO4 3. All right, so that is the formula. Al2 SO4 after the bracket 3. Chemical reaction takes place, and then what we get? We get aluminum chloride. So let's now find the formula of aluminum chloride. So aluminum chloride, let me write it here. So ALUM, let me just write short for aluminum chloride, CHLORID. Aluminum ka symbol is Al. Chloride is chlorine, so you'll be writing Cl. Now valency of aluminum we already calculated, it's 3. Chlorine ka valency is how much? 1. So 1. Cross multiplication. So the formula is Al into 1, which is L, and Cl into 3, Cl3. So the formula is AlCl3. So what you're getting? You're getting AlCl3 plus the next one is barium sulfate. So no space for barium sulfate, so let me erase this one. Barium sulfate. Barium sulfate, BARIUM, and barium sulfate. So barium is Ba, and sulfate is, we know na, SO4. SO4. Barium, what is the valency of barium? 2. So 2. Sulfate valency is also 2, isn't it? It's 2. Okay, now you see. We can, okay, we'll first do cross multiplication. Put a bracket, don't forget to put the bracket here. So cross multiplication will take place. Cross multiplication will take place. So the formula is B. Okay, better do like this. Cut, make it simple. Make it simple. Okay, make it simple. We can cut in the formula also, but we can do it here also. So you do it here. So 2 ones are 2, 2 ones are 2. Make it lowest. Make it in the lowest term. So Ba into 1, Ba, and then SO4 into 1, it will be SO4. Okay, no need to put bracket because here though, see, nobody's here. Okay. Yes, I can tell you that why we are putting bracket is because this tree, okay, this tree is there. If it is 1, then it's not necessary that you put a bracket, which I'm doing here. Okay, it's 1 here, so no need to put bracket. You can always put a bracket, but it's irrelevant to put a bracket if the number here is 1. But if it is more than 1, 2 or 3 or 4, always put bracket. If you don't put bracket, what happened? You know, some of you will write like this, 43. It's wrong, isn't it? It's wrong. So to prevent this error, put the bracket. Understood? So it's BaSO4 now. So the formula is BaSO4. So BaSO4. Let me drink water. My throat is dry. I need to drink water. Speaking, the throat becomes dry. Okay. Please don't mind that. So BaSO4. So BaSO4. All right. Now we are done with the skeletal equation. What is left now is balancing. So let's balance it. So you know what we do? We draw a line here. These are the reactants. So from the reactants, we will identify the elements. So let's start from here. So barium. All right. So okay, I'll do one thing. All right, here barium. Then chlorine, Cl. Then aluminum is here. Okay, I'll use this space. Okay, aluminum. Then sulfur is here. Then oxygen is here. O. Then this side, the same elements will be found. So Ba will be found here. Ba is here. Then Cl will also be there. Then aluminum is there. Then sulfur is there. Then oxygen is there. Okay. Now let's count the number of atoms. How many barium? 1. So you can write here 1. How many chlorine? 2. So you can write here 2. Nah? Okay. Then how many aluminum? 2. So we'll write here 2. Then how many sulfur? Remember, see, this 4 belongs to oxygen. Okay. This 4 does not belong to sulfur. It only belongs to oxygen. But remember, this 3 belongs to both oxygen and both sulfur. It's both sulfur and oxygen are bounded by a bracket. Outside the bracket, you have 3. So this 3 belongs to oxygen also. This 3 belongs to sulfur also. So this sulfur belongs to this S. This 3 belongs to sulfur also. So 3S. And then what about oxygen? Oxygen will be, bracket means into. Okay, so 4 3s are 12. So we have 12 oxygen. All right. Then let's go to the product side. Barium is here. How many barium? 1. All right. Then chlorine is here. How many chlorine? 3. Then aluminum. How many aluminum? 1. Then sulfur. How many sulfur? 1. Then oxygen. How many? 4. Okay. We don't have any oxygen here. Here 4. So 4. So who needs balancing? Okay. Barium is already balanced. 2 chlorine, 3 chlorine. Chlorine also needs balancing. Then 2 aluminum, 1 aluminum. Aluminum also needs balancing. 3 sulfur, 1 sulfur. Sulfur also needs balancing. 12 oxygen, 4 oxygen. Oxygen also needs balancing. So we'll follow the first rule, which is oxygen and hydrogen first. So we don't have hydrogen here, but we do have oxygen. So let's balance oxygen first. So it's 12 here. Okay, it's 4 here. So less is here. So we will be doing here. Okay, we'll be adding the number here. So let's try to make it 12. Okay, we'll try to make it 12. So 4 is already here. So 4 into what number will give you 12? 4 into what number? What number should I write here? Which will give me 12? 4 into 3. So this 3, where will write? You will write here 3. Okay, you will write a 3. Now remember, this 3 will act like a bracket. This 3 will not act like a bracket, sorry. This 3 will belong to everybody, so remember that, okay? The 3 will belong to everybody here. So I'm just putting a bracket to let you remember that 3 will belong to barium also. So let's do the correction first, okay? First do the necessary correction, because you have just written a number before the compound. So do the necessary correction. So 3Ba. So this will change to 3, okay? Then 3 into S, 3S. So this will also change to 3, okay? Then 3 into 4 is 12, isn't it? So this, we got this 3, okay? Because we are balancing oxygen first. So 3 4s are 12. Oxygen is balanced. 12 oxygen, 12 oxygen. Okay, done. Now after that, we can start with anything now. No? Okay, we have, what do we have? Sulfur seems balanced, so good. Chlorine not balanced. Okay, then okay, whom do we do now here? Here, with whom did I touch here? With these 3. What did I touch? Barium, 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 barium. We can do with barium, nah? Barium, see. 3 barium is here. Okay, now the oxygen, hydrogen we started. So remaining elements are aluminium, sulfur, chlorine, barium. You can start with any one. Okay, but then here, by writing these 3, barium and sulfur has been affected. So I want to address them first. Okay, so that there is a pattern, so that I don't forget. So I want to start with barium. So 3 barium here. So let's come to this barium on the reactant side. Only 1 barium is not. So 1 into what number will give you 3? So easy, na, sir? So easy. What is that? 3, isn't it? 1 to 3. So you put here 3. So you put here 3. So 3 barium, remember, this 3 belongs to chlorine also. So 3 2s are 6. So the chlorine number will shoot up to 6. Okay? Chlorine number is shoot up to 6. Okay. Then, what about this? 3 sulfur. 3 sulfur, only the sulfur is balanced. So the only thing which we need to balance now is, okay, aluminium not affected. Now chlorine is there. So let's balance chlorine. So chlorine 6 here. How many chlorine? 3 here. So 3 into what number will give you 6? The answer is 3 2s are 6. So you put here 2. Okay, you put here 2, then 6 chlorine. Now, so these 2 will belong to aluminium also. So 2 aluminium. So this will change to 2 aluminium. Remember, this 2 into aluminium, 2 aluminium. 2 3s are 6. So 2 aluminium. Okay, 2 aluminium here. Now let's check aluminium. 2 here on the product side, 2 here on the reactant side. Okay, I think everything is balanced. 3 barium here, 3 barium there, 6 chlorine, 6 chlorine, 2 aluminium, 2 aluminium, 3 sulfur, 3 sulfur, 12 oxygen, 12 oxygen. I think it's balanced. Let's confirm for the last time from the skeletal equation. 3 barium. Let's go to the product. 3 barium. Okay, balance. 3 2s are 6, 6 chlorine. 2 3s are 6, 6 chlorine, balance. 2 aluminium. Where's my aluminium? Here, 2 aluminium, correct. 3 sulfur, 3 sulfur, correct. 4 3s are 12, 12 chlorine, 12 oxygen, sorry. 3 4s are 12, 12 oxygen. So this is it. This is the balanced chemical equation. Okay, balanced skeletal equation for the question number C. Okay. So kindly copy it down. I will erase it. Okay, I'll move to the side for once. You can copy it down. All right, assuming that you have copied down, let me erase this and let's do the last question. I don't know how lengthy the video is going to be. I think it's going more than an hour, but can't help. Okay, my dear students, can't help it. So even if the video is lengthy, please bear and watch. The advantage of YouTube recorded classes is that you can pause the video and rewind, watch it at 1x, 2x, 1.25x. Okay. I also watch videos at 2x speed. Okay, when I don't have time. Okay. Initially it was little odd, but now though I'm used to it. All right. Then let's do the next question. Question number D. Potassium metal reacts with water to give potassium hydroxide and hydrogen gas. So let's balance this. By now I know that you can do it by yourself also, so you have become an expert. Potassium metal reacts with water to give potassium hydroxide and hydrogen gas. My throat is getting dry again. I nearly spilled. What I nearly spilled? I spilled it. Okay, it's not I nearly spilled. I already did the egg. All right. So potassium metal reacts with water to give potassium hydroxide and hydrogen gas. So potassium. Okay. So we have read the statement, and then what caught your eye? Potassium. Potassium is an element. So element. So just the symbol will do. So potassium ka symbol. What is the symbol of potassium? P, na? Yeah, it's P, na? No, it's wrong. It's not P. Yes, it is not P. What is it? It is K. Okay, potassium ka symbol is K. K reacts with water. So plus water is H2O. You know that. To give means the reaction takes place. Potassium hydroxide. So potassium hydroxide is a compound. So we have to find the formula of. We have to derive the formula of potassium hydroxide. Let's try. So we know how to do now. So let me write here. Okay. So potassium hydroxide. So the first step is write the symbol. So potassium ka K, hydroxide. Hydroxide is a polyatomic ion, OH. So right here OH. What is the valency of? Now we have to write the valency. This was the symbol. Now we have to write the valency. Valency of potassium. What is the atomic number of potassium? 19. So how do we do this? First shell 2, second shell 8, third shell how much? 8. 8 plus 8, 8 plus 2, 10, 10 plus 8, 18. So already 18 electrons are accommodated. 1 is still left here. 1 will go here. But 1 in this fourth shell will be unstable, is not. So what sodium will do? Sodium will discard this. Sodium will lose this electron. So valency becomes 1. By losing this, okay, sodium becomes stable. So valency is 1. So sodium valency is 1. Hydroxide valency. Do you see any number here? No. Okay, these valencies are here. These are the valencies. Okay, for carbonate the valency is 2. For sulfide is 2. For sulfate it is 2. For phosphate it is 3. So the valencies are at the top. Okay, so you don't see, that means 1. So now what you need to do? Cross multiplication. So the formula is K into 1, which is K, OH into 1, which is OH. There you go. Okay, so the formula of potassium hydroxide is KOH. So KOH plus hydrogen gas. Hydrogen is a diatomic, so we write here H2. So we have successfully written the skeletal equation of the chemical statement. Now we go to the next step, which is balancing. Let's bring about balancing. So these are the reactants and these are the products. So first, step 1 to balance the chemical equation. Step 1 is identify the elements. So let's identify the elements. We'll start from here, which is K, then we have hydrogen, then we have oxygen. Now the same elements will be there, so just copy paste it, okay, without wasting time. Now second step, count the number of atoms. So how many K? 1. So write 1 here. How many hydrogen? 2. Write here 2. How many oxygen? 1. So write here 1. Now how many K? 1. How many hydrogen? 1 here plus 2. 2 plus 1, 3. So 3 hydrogen. How many oxygen? 1. So potassium is balanced. Oxygen also is balanced. Hydrogen is not balanced. All right. So balancing, while balancing, rule number 1, always start with hydrogen and oxygen first. So we have hydrogen which needs balancing, so we will start with hydrogen. Okay, now so this is also the important one. So again, don't forget to put star mark here. So once again, we have come across that type of question which is considered as a challenge by some students, okay, but not you, okay. You don't consider it as a challenge because now you know. So not for you, okay. It's not for you. You are not that, you don't consider this a challenge. This is very easy for you now though, okay. So let's try how easy it is. Now we observe we are to balance hydrogen. Now look at hydrogen here. You will find hydrogen here and you will find hydrogen here. Both the reactants have hydrogen. Okay. Oh yes, I remember now. So in this scenario, how did we do the previous question? Yes, we go to the second rule, which is make it even. So now you follow the make it even technique. So here the number of hydrogen is 2. Is even, is it not? 2 is an even number. What is the number of hydrogen here? 1. Is it even? No. So let's make it even. Okay. So how do you make it even? You are not supposed to write anything here. You can write it here. So you write here 2. Okay. So this 2 belongs to hydrogen. This 2 belongs to oxygen. This 2 belongs to K. Okay. So 2H. Okay. So this has become even. So 2H plus 2, which becomes 4. So the oxygen number has changed to 4. Now keep oxygen like this. Okay. Just keep it like that. Bring the necessary changes. Okay, do the correction by writing 2 here. Remember, this 2 belongs to K, this 2 belongs to oxygen also. So this 2 belongs to K, so this becomes 2K. Don't forget to do the changes. This 2 belongs to oxygen, so this becomes oxygen to really done. 2A, sorry. This 2, oh why? Sorry. What am I doing here? Oh, my bad. I should be writing it 4, nah? It's my bad, sorry. So we were talking about hydrogen and then by mistake I went and did it on the oxygen. Okay, very sorry. So it should be 2K done. Okay, 2 plus 2, 4. Now we have made it even, isn't it? Okay, so now the number of oxygen has become 4, hydrogen has become 4, and 2O, 2AO, yes, this will be 2O. Okay, so 2 into K, 2K, 2 into O, 2O, 2 hydrogen plus 2 make it 4. Okay, I hope it's clear. All right, now we have already done with hydrogen, so don't touch it now. Now oxygen and hydrogen first. We started with hydrogen. Okay, remember we started with hydrogen. To make it even, we have written 2 here. Now we go to oxygen. Let's go to oxygen. So oxygen is here, but it's not balanced, is it not? So oxygen and hydrogen first. That is the rule. So hydrogen done. Let's go to oxygen. So now let's balance oxygen. So this side is 2, so 1 only. So we have to make this side 2. So 1 into what number should I multiply so that it become 2? Very easy, 2. This 2 where you write? You write it here, 2. Okay, so you write 2 here. So this has become 2 oxygen. But then this 2 will also affect hydrogen, so 2 to the 4. So hydrogen, yeah, 2 to the 4. This becomes 4. I'm getting confused, yeah? So 2 to the 4. Okay, so hydrogen ka number C automatically balanced, na? All right. Okay, then what is left? Well, hydrogen balance, oxygen balance. So now you can do with anybody. Potassium is only left, so you balance this one. 2 there, so we have to make this side also 2. So 1 into what number will give you 2? It's 2. So you put here 2. So let's confirm. 2K balance. For hydrogen, 2 from here plus 2 for hydrogen. 2 oxygen, balance. Balance हो गया. Balanced. Okay. Well, I hope now though that you have become an expert in balancing a chemical equation. I pray that you are now more than confident to tackle any balancing the chemical equation questions. Okay, so thank you so much, my dear students, for tuning in and watching the video. All right, in the next video we'll be discussing about the types of chemical reactions, combination, decomposition, displacement, and double displacement. So don't forget to tune in, okay, and keep watching, keep learning, and continue the support. All right, so until next time, I pray that You will all take good care, and God bless you all.